the greater the amount of magma being produced.
For what we have known in the past, never we have had such a big amount of gases. Never.
Jacques Derieux.
The satellite identifies the gas as sulfur dioxide, SO2, the primary cause of acid rain. And Nyiragongo is producing more than any place in the world, up to 50,000 tons per day. That's more than the amount produced by all power plants, factories, and cars in the United States. And the high concentration of SO2 is another clue for forecasting the next eruption.
If we see high concentrations of carbon dioxide, that's often a reflection that we have magma at greater depth.
Barry Cameron.
But when we start to see large amounts of sulfur dioxide being released from a volcano, it's an indication that we have magma at very, very close to the surface and potentially erupting in a matter of days or weeks.
Derieux and his team are breaking new ground at Nyiragongo by gathering scientific data in order to forecast the next eruption. But they are uncovering some very alarming clues. The increased seismic activity is the result of tremors caused by magma moving beneath the earth.
A white plume of gas rises from Nyiragongo.
The enormous emission of sulfur gas is a clue that a huge quantity of magma is near the surface. And the thermal data shows Nyiragongo's fracture zone is extending toward the city. With no lava visible in the crater, and the satellite showing deformation of the land around the volcano, it could mean that magma is moving into the fissures.
Animation shows the fissures beneath the city of Goma.
Such a stock of magma under the volcano could trigger an eruption anytime and anywhere.
This emerging picture could be the worst possible scenario. Nyiragongo may be storing this huge amount of magma throughout its deadly web of fissures. Even worse than the devastation of 2002, Nyiragongo, with the fastest flowing lava in the world, now threatens to erupt right beneath the city of Goma.
A fiery wall of lava spews above treetops. Now 2 UN jeeps drive on a rural dirt road. Later, a guide slashes through tall plants with a machete.
To discover just how imminent the threat might be, Tedesco, Vaselli, and a researcher from the Goma Volcano Observatory gathered gas samples all along Nyiragongo's web of fissures.
A small pool of water bubbles and churns.
If you have a spatial set of samples, in other words, one that's collected in the crater, and then a series of samples that are collected outside the crater, that gives you a way of understanding the plumbing system in the volcano.
Tom Casadevall.
Gives you a sense of how open that fissure system is between the crater and the outer flank.
At this thermal spring, they measure temperature and chemical composition.
Chemical composition, isotopic composition give us exactly which is the source of these gases.
Dario Tedesco.
The team checks this fissure with a device called a sniffer.
A researcher places a probe into a gaping 3-foot deep crack.
All volcanic gas contains a mixture of water, carbon dioxide, and sulfur dioxide. But their ratio can be an important clue.
Tom Casadevall.
If we were to find a high temperature gas with similar water, CO2, sulfur gas ratios on the outer flank of the volcano, it would give us an indication that perhaps magma is very close to the surface.
Footage shows a wave of lava blasting into the air.
But the buildup of magma in Nyiragongo's fissures is not the only threat to the people of Goma. Here they are reading a